My name is Hazem, and today we're going to look at flammable liquids. So, when we transfer a flammable liquid between two containers, we must eliminate ignition sources. So, that includes sparks, tobacco, smoke, welding, grinding, or static electricity. Because when we move a liquid, so if I've got a beaker, for example, and I'm pouring it in to another beaker, and there's a spark here that could cause a fire right there. So the first thing we want to do is ground ourselves and ground fuel tanks with a ground rod and cable. So this mostly applies to gas stations. And then we want to store as little liquid as possible and remove portable fuel containers from vehicles when filling them. Now, gas containers are always red and diesel containers are always yellow. And do not store flammable liquids near an exit or anything dangerous or where they can have a really high temperature or pressure or physical extreme. Or you can only store flammable substances in what's called an approved container. Now, remember, we talked about gas cylinders. So, when we transport a gas cylinder or store it, we must do so with manufacturer specifications, and we have to be careful to protect the fittings at the top because these are extremely sensitive, and if they don't tolerate much physical damage, and if you break it, all the gas comes flying out. So always secure them in an upright position so they don't fall over. And if you've got a valve cover that protects the valve, install the valve cover and secure it so that it does not dislodge. So these can be stored in like a really big truck. Don't put them in the trunk. And obviously provide adequate ventilation. So here's these are gas tanks that are hooked up to something and they are chained together so they don't fall over. So this is safe. And then here we're moving them, so we've got a dolly and we've chained the tanks to a dolly. Um, this looks like so they can move them and use them in the job site. Now, third, we need to look at what we call incompatible materials. So if you look here, acids and bases, so there's certain chemicals we must never mix together. And one is an acid or a base. So anything corrosive should not be mixed with a reactive metal. So reactive metals include aluminum, beryllium, calcium, lithium, potassium, magnesium, sodium, or zinc powder. Now, pure zinc's okay, but zinc powder is reactive. So if we if we mix these two together, we got a fire, which is bad. We also don't want to mix a organic solvent like an alcohol, an aldehyde, or a nitrated hydrocarbon. So those are anything that ends in OH chemical formula or uh, CN whatever. So if we mix that with an acid or a base or a reactive metal, we get an explosion, which is worse. And then we don't want to mix a flammable liquid with anything really, because you get a fire or explosion or some other violent reaction. And then we can't mix a flammable gas with an oxidizer that gives us a fire as well or an explosion. We don't want to mix cyanide or sulfur with an acid. That gives us a fire. And then we don't want to mix an oxidizer with any kind of flammable material. That gives us an explosion. So oxidizers include um, acids, nitrates, perchlorates, permanganates, peroxides, chlorides, chlorine, and chlorates. So if you see this word in the chemical, so potassium permanganate, that's a permanganate. You cannot mix that, say, with gasoline or something. You get an explosion. And then we must ventilate the workspace when there is an airborne or biological contaminant, or when there's a hazardous dust, gas, fumes, mist, aerosol, smoke, or vapor, or flammable levels of any kind of material. Now, or we must ventilate when we have less than 19.5% or more than 23% oxygen by volume. And the reason is oxygen is what makes fire, but we also need it to breathe. So between 19.5 and 23%, that's the sweet spot where we can breathe really well without having too much of a fire hazard. If we go less than 19.5, we get no fire, but nobody can breathe very well, especially you can't really breathe at less than 18%, so you need fresh air. And more than 23, you can breathe, but you have a huge fire hazard. So when we're doing a ventilation, here's a guy welding and he's creating some noxious gases. So we've got a fan on the roof which is pushing air in, and then we've got a fan on the wall which is exhausting the bad air out. And these two airflow rates should be the same. Now, this is beyond our scope, but if we go to the ASHRAE handbook, the ASHRAE handbook American Society of Heating, Refrigerant, and Air Conditioning Engineers, it tells us how much air a building needs, and it tells us that as air changes per hour. So if we can figure out how big the building is by volume, let's say it's 1,000 cubic meters, let's say 1,000. So then it will say, let's say we need 10 air changes per hour, then that means we need 10,000 cubic meters of air coming in per hour. Or if it says 5 air changes or it says 25 air changes, the number of air changes depends on the activity. And it can also depend on the number of people. So, oh yeah, that's right. So, how much ventilation do I need? Well, if we make some really bad fumes and they clear within 30 seconds, then the ventilation is adequate. And that's a good rule of thumb, but it's a target's like 4 to 6 air changes per hour. So like I said, if your building is 1,000 cubic meters, for example, then you need 5,000 cubic meters of air per hour. But you gotta look at the handbook, because the handbook is it's pretty much a standard everywhere in North America and Europe as well. So if it tells you you need 10 air changes per hour for the type of work that you're doing, then you need 10. If you only need 3, then you only need 3. So that's important. Now, if I'm so this is expensive, but it's great for like if I've got a welding shop. Let's say this is I weld stuff in here all day, every day. So I want to have a ventilation system put in. It's great. But now, say I'm only welding a tiny little thing, then I can set up a portable vent, which is like a local vent. So we call that source extraction. And it can be fixed or flexible, and it can allow you to position the duct next to the work area and remove the fumes. So this guy is maybe welding something temporary, so then hey, that's great. And then we've got smoke extractors. So this is a standalone machine. So what it does is it sucks the smoke out. It sucks the air out with the smoke, and then it pushes the air through the filter, and it removes the smoke, because smoke is air with like little particles in it. So if we capture the air and push it through a filter, then the filter's got the particles, and we've just got pure air that goes back. So these are great. And then you just change the filter when you need to. Any questions? Please leave a comment.